Now I'm going to open up the course content we are going to cover. I'll give you a quick overview about the course content here. So in the Wireshark class, for the first lab is we'll help everyone to install Wireshark, and we'll walk you through Wireshark hands-on and what are the profiles that can be used in Wireshark, and configuring profiles, adding custom columns. Example, if I want to make this as a fill column, if I want to apply this as a column, and I can apply this as a column. So very quick, use of this column. Example here, identification. For every IP, there is an unique identification number. Example, if you come down here, if you see this is 192.168.0.38. And if you see from here, for all these IPs, can you see the identification number, IP identification number that's going to be unique for every single transaction between the server? So it means from this, I can figure out, okay, my communication is successfully happening between source and destination, and my identification number is always incrementing by 1. And this is all the random number that's been assigned by the operating system. And I'll tell you, for some servers, for developers, they want to hide their information. If we are tracking that, they may feel this is that is a security breach. Some servers, they can hide this identification number that can also be 0 at times. That depends on the developer, the application, what we use. But from this, I can have a quick track about, okay, my communication is actually happening to the server. And if you're getting a different, if you get a random number from the server, it means that it is busy and it is talking to other clients. So from here, I can understand, okay, the server is really busy and I have a connection to the server. There is nothing problem with the server, maybe something with the client. So we'll get to know about deep understanding about this IP identification. This just for demonstration, I have shown this. So we have a topic of IP identification. Likewise, we got, deep explanation for every single topic we discuss here. And we see the coloring traffic, how we do a coloring and adjusting the screen layout and configuring the Wireshark interface. Right, you can select the interface when you fire up your Wireshark. You can select the interfaces, the actual interface where your actual traffic is going. You may have multiple interface, but where is my traffic is going? Now it's going on my Wi-Fi. So how do we specify that, and how we capture traffic on a specific interface? An introduction to Wireshark filters. We have different filters for IP address, source, destination, protocols and numbers. HTTPS, it uses 443. Likewise, for we have different option filters. We'll look at every single filter that's possible filters that we use in Wireshark, and we use operators. As we see here, it's a not IP.destination, and the combination of packets will be added with IP.address, and IP.address is something like I'm using source and destination. So I have to give something like this. So I'll give IP.address equal, and the IP address 10.0.0.1 and IP.address equals 8.8.8 for google.com. So you'll do all this. It's a one example. So likewise, we use different operators here, and we'll create a display filter. This is all display filters we have here. This is called as display filter. And how to capture in a switch environment. Example, if you're working in the enterprise and you want to do a span port, if you want to offload your traffic from your switch, how do I do that? So you'll understand everything. We'll do a demonstration. I'll do a lab for it. So example, if you got a switch, and this is your switch, and this is your PC, where you're logging to your other other switches in your enterprise. And if you want to offload this traffic, the traffic that goes to the trunk interface, and how do I offload this traffic back to this PC? So this particular port will be made as a span port. It will be in monitoring mode, and all your traffic will be asking for your destination port, source port and destination port, both you have to define. So this is your destination port and this is your source port. So I'm going to offload all this traffic from source port to destination port. So what happens inside your Wireshark, you will see all the traffic that is actually going through this trunk. Actually, the traffic that is going through trunk will be captured inside your Wireshark. So I'll do a lab for it and we'll check the protocols, every single detail inside. And I have given so many topics here. So we'll see OSI model, step by step, every single packet, Ethernet header. Because we should know about Ethernet header, because if there is a cyclic redundancy check error, if there is a problem with your cable, so error keeps increasing. So how do I find that? So we'll see what is inside the frame header, every single parameter inside the Ethernet header. Then we'll differentiate how we can differentiate unicast, broadcast packets, multicast packets in Wireshark. And this is about the layer 3. So analyzing multiple capture points, and analyzing a packet, digging deeper into your IP ID. We defined, right? That is identification number, digging deeper into IP ID, how to use the TTL field. As I said yesterday, TTL is very important, and where you can, find is it really the routing is happening or not. If your TTL is not decrementing, then there is a problem with the routing. So how this IP fragmentation works, and IP flags, and you'll see about IPv6. And as I said, configuring Wireshark to find geo IP locations to mitigate the DDoS attack. Then in the URL practical, UDP practical, you will get to know UDP is more with this video streaming. So you will analyze DNS and how this UDP is used by all this application, DNS, DHCP. So we'll see what is the header value, how DHCP works, and how do I troubleshoot that. So we have a lab and troubleshooting VoIP and video streams. And we will do the hands-on with TCP flags and list of options we have for TCP. And yesterday we saw what is sequence number, acknowledge number, how it works, and digging into retransmission. Why retransmission happening? It's because of routing loop, or it's because of the servers not responding. So what is FIN flag? What is reset flag? And you will come to know, is it a client, network, or server? These three are the possibilities. So we have a lab for every single topic and a TCP analysis. So most of the application, they use TCP. So we'll find how the slow application response time, you will find out high network latency, network packet loss, slow file transfer, and network application disconnects. TCP reset happens because of that. Yeah. So all the topics, for every topic, we have a lab. If you look at this UDP, you have a lab for UDP. See, this is all labs. TCP lab analysis. This is troubleshooting labs. And for every topic, we have a lab. For all the topics, whatever we discussed, we have a lab. So this is about, a brief overview about the Wireshark course. So let me unmute now so you can ask your questions. And you can unmute yourself and you can ask your questions. Am I audible?
Yes.
Okay. Anybody have any questions about the course content and about the course? You're most welcome to ask your questions.
Hi, sir. Is there any recording available for class 1, yesterday class?
I think, yeah, we should have a recording for class 1.
Is it available on app?
I'll let you know shortly. I'm not sure. I mean, it's recorded and we have, and I'll talk about how we can share the recording
Thank you.
by end of this class. Yeah.
So Arjun, this is Venkat. So this 2 days class is covering entire Wireshark, or in your lecture you said your some real-time classes are there.
No. This is just a demonstration, and this is just a webinar about giving insight about Wireshark, how it works, how we apply filters. Because most of them maybe they might not started their profession with Wireshark, and they may not be working on networks a lot. So the intention is to give a glimpse about Wireshark and what is the use of Wireshark and how do we do capture and how exactly it works with the networking protocols and how we can do the filtering and capturing.
Okay.
So just one question. So can you just explain the retransmission with the help of client and server?
Yesterday we discussed about the retransmission, right?
I was having some doubts. So
okay.
No, basically how the retransmission is happening because of what reason?
No, let me open up the capture. So it's here. Duplicate acknowledgements. Let me take this. Yeah. Tell me, yeah, we can look at the TCP duplicate acknowledgements. It's similar to retransmission, yeah.
Okay.
Yep. Your question?
Basically, I just want to know because when we have the client and server communication, right?
Yeah.
And so if just correct me if I'm wrong. For example, when we are sending a packet, okay, we will be for every packet whichever we are sending, we should get the acknowledgement back from the other device, right?
Yeah, that's right. Yeah.
So if we are, as per my understanding, if I am not getting, if for example I'm sending a packet, I'll be having some timer on my end. If I'm not getting the acknowledgement back, okay, from the peer within a time, then only I'll go ahead and retransmit the same packet, right?
Yeah, that's right. Yeah.
Okay, if that is happening, how we can see? Because yesterday I believe you are saying we have client A and the server B. Okay, if the client A is retransmitting the packet, as A was not getting the the acknowledgement back from the server B, we should troubleshoot that, right? Instead of we should focus on the retransmitted device.
Sorry. The final part, what did you say? I don't understand.
See what I'm saying? I have client A and B. Okay, for example, I have sent the packet to B. Okay, I'm waiting for the acknowledgement for some time. I didn't get that one, so the client A has retransmitted the same packet, right?
Yeah, that's
okay,
right.
Now, yes. In that case, we should troubleshoot why the acknowledgement we didn't get back from the server, right? That's where we should troubleshoot, right?
Yeah, exactly. Where the connection broken and where exactly we started this we started seeing the retransmission. That's when your problem starts, and there is exactly the problem is when exactly the retransmission
that's
happening.
What the confusion. Yeah, that's what the confusion, because for packet, if you are looking there on the Wireshark, there will be source and destination, right? For example, I'm seeing continuous white retransmission packet from the client. That means I'm not getting the acknowledgement packet from the server, right? So in that case, how we can we can tell the client is making the problem?
See here, what is the source? Who is sending this TCP duplicate acknowledgement? So it's sending, it's a client, right?
Exactly.
So this is a server. By looking at it, we'll know, okay, this is a client, and it is it is keep on sending this duplicate acknowledgement. And see, you can see it's filled up a lot. So it's a problem with the client. And we have to figure out from there why it's happening. It's because of routing, or it's because of latency, or it's because of the server. So we have to, but we got a clue, okay, where exactly the problem is. It's a client or server. That's the first catch. Then you have to drill down about your issue. Yeah.
I got it. I totally understand that point. But logically, when I'm thinking, the packet and the acknowledgement, see, it is sending because it didn't get the acknowledgement back from the server, right?
Yeah, that's right. Yeah.
Yeah. Then we are going to drill down, the issue on the client, and that's what the confusion is happening for me.
Yeah, because if you see, you can do this. If you follow this, not following the stream, if you see the conversation filter, and if you do a TCP, now you see the conversation only related to 192 and 104. So if you see here, so this is an intermittent issue. So from here, see here, it is the TCP handshake is successful. I see SYNAC ACK, and the TLS handshake happened, and your data is keep low. If it's going really well, and I'm just following the stream only between this source and destination. So if I drill down here, exactly the first problem started. Here there is a retransmission, right? If I look at it, okay, from here I have to figure out, okay, from this point there is no problem. So from here, who is doing this retransmission? Now it is from the server. Now it is from the server. Yeah, the server is retransmitting. Now here you got a clue. So it is retransmitting to who? The client. Yeah. And if you see your TCP out of order packets, that's happening for the client, because this client is asking for the retransmission, right? This is not a server again. You got it what I'm saying? So the retransmission is happening from the server to the client. So again, it's a problem with the client, because the client is keep sending this duplicate acknowledgements, because it didn't get a specific segment from the server. You got it what I'm saying? So this is retransmitting back to this client. And if you see TCP out of order, and if you see that this completely the client, it keeps sending this duplicate acknowledgement. So here there's a server. If you see, drill down, where is that? We saw that, right? A list of conversation where it happened between the client and server.
Yeah, I saw that.
Where is it? So see here, list of duplicate acknowledgements is happening between the, because here the client is a culprit, and the client is not, receiving the packet. Is something problem with the client, when we have to figure out why. We have to reproduce the issue, and we have to do the capture, and we have to figure out. Yeah.
Hello, sir.
Yeah.
Sir, what is the duration of this class?
You mean, yeah, you just contact to this number, we'll give all the details.
Okay.
It approximately, it will take 50 hours.
50 hours.
Yeah.
And sir, if any case, actually what happened, our switches are sometimes down. Okay.
Sorry?
And, in our environment,
Okay.
So we have many switches. Okay, so sometimes that switches are down.
Okay.
So how we just capture that? Exactly what happened, that some devices send the broadcast. Many devices are there, all are Windows system, and sometimes they are doing broadcast, and that's why the so switches is hang. So how we capture that one? Is it any way?
No, switches, then if the switches is not responding, then you can do continuous ping to it, and you can capture from your PC, right? Where the PC where you try to manage those appliances, you can do that.
we can capture the data on, is it possible?
Yeah, that is possible. As I told you, see, example, if the switch goes down, right? So if the switch goes down, example, let me open up this. There's my whiteboard. See, as I told you, in the Cisco switches, you can do span port. Example, this is your PC. You have a wired connection back and you have your Wireshark here. The Wireshark is running, and if you make this port as a span port, and this is your actual traffic is going to a trunk to other switch, right? So
Yes,
if you are connected to this switch, you can offload all your trunk traffic, I mean the trunk port traffic to your PC through you have to specify inside your span configuration, you have to specify your source port and destination port. So when you give the destination port as your PC is connected here, right? So if the destination port is your PC, then all the traffic that is traversing between these two switches, you will see all this traffic, all the protocols inside your Wireshark inside your PC. Yeah, live capture. And you can save it later, and you can check it why the switch goes down. And it's all about depends on the specific protocol, right? If you're doing some VLAN config mismatch, or if it is your port channel, you can see the LACP communication, and you have more insights about every protocol. It's up to you then where you're interested to see. Okay, if your connection is breaking, it's something because of VLAN or it's something because of a port channel. If you are giving, if your port channel should be, if you have a port channel connection between two switches, the VLAN should be similar. If there is a VLAN mismatch, your port channel will be broken. So you will see the LACP is broken because of VLAN mismatch or why it is broken. And you will get to know all these details when you offload this traffic back to your Wireshark and you do an analysis. This is one typical example I am giving. So it depends upon your scenario, what is the issue you're facing and which protocol you want to see.
okay, sir.
Yeah, hi, it's Prem here. Could you please explain about the spam configuration, spam configuration?
Okay. So spam configuration is, okay. You got a switch and you have a hardwire connection with your PC. And this is an uplink connection to your switch. So what I'm saying is, so inside the spam configuration, you can specify your source port and your destination port. And there is an option for your VLANs also. Only if we want to capture a traffic for a specific VLAN, you can do, or you want to do all the traffic, you don't need to specify your VLANs. You have to define your source port and destination port. So once you configure this spam configuration, the port goes to monitor mode. And it starts to monitor all your traffic. Now, how I can offload this traffic? I have to give the destination port. So if my destination port is something like GI0/2 and my source port is GI0/1, so all my traffic will be offloaded back to this port. And I should open a Wireshark when I do that. And inside the Wireshark, you will see all the protocols like DNS, your DHCP, your UDP. And you have to look at what exactly you wanted from this, which particular protocol you suspect that it could be a problem with a specific protocol. You can drill down and you can find.
Can we configure the only as a source interface or destination in physical interface, or we can configure a logical interface like LT or interface?
No. That is not possible. I mean, logical interfaces, actually the real traffic is not going through the logical interface, right? That's just for communication. You have to specify the physical interface. Yeah.
Okay.
Because your actual traffic you have to offload, so you cannot do that with logical interface.
All right. Thank you.
No problem. Yeah. Any questions related to course content? You guys, if you have any questions related to the course content, you can ask questions, or maybe if you're welcome to ask any questions, but I'm saying if you have anything to be discussed or you need clarification about the course content or what we are going to learn, you can ask your questions. Feel free to ask your questions. I'm welcome to answer you.
Yeah, one more question. So what types of attacks in DSCP?
What? Sorry?
Types of attacks in DSCP.
DHCP starvation attack is the one I am aware of. DHCP starvation attack is the client keep on sending the DHCP request and the server will be giving all the IPs to the one PC. Since as many DHCP requests I get, I'll give an IP back. That is DHCP starvation attack. So once the scope is completely utilized, so all the other clients in a network cannot get an IP address.
Mhm. Okay, and how can mitigate that?
You have to do DHCP spoofing.
Okay, all right. DSCP is perfect.
Yeah.
Thank you.
No problem.